warm blue waters off the coast of Hawaii, a scene of incredible beauty, but a world in transition. Ironically, this piece of coral, delicate as fine china, is also a sign of trouble.
Today, we are facing the potential loss or massive degradation of all of our reefs.
Down here, climate change is taking its toll.
So this is essentially telling you that this coral is not dead.
But a team of scientists is trying to engineer survival in an extreme future.
What you're talking about here is epigenetics,
Absolutely,
right?
rapid adaptation.
Will it work? This is TechKnow, a show about innovations that can change lives.
The science of fighting a wildfire.
We're going to explore the intersection of hardware and humanity, and we're doing it in a unique way. This is a show about science by scientists. TechKnow investigates a coral catastrophe.
Hey guys, today we're going for a dive and we're talking coral reefs. I'm joined by Dr. Crystal Dilworth and Marita Davison. And it sounds surreal to say, but it's possible that within our lifetimes, all the coral reefs will be gone.
Scientists are saying that without some drastic changes, 100% of our coral reefs are facing degradation by 2050, which is only 30 years away.
It could be an ecological disaster.
And the problem is they're being attacked on all fronts. Right now, they're going through this global bleaching event where all the corals are basically starving.
Yeah, and this bleaching event is affecting, right now, 40% of coral reefs worldwide. Hawaii has been particularly hard hit. I got to go there to check it out and see if there's anything we can do to save the coral reefs. Kaneohe Bay on the eastern side of Oahu, Hawaii. Famous for clear blue seas and coral, rich in color and marine life. But now there's trouble in these waters. The coral is dying. In fact, reefs around the world are in trouble. We're here to find out why.
Some reefs have recovered much more quickly than others, and we're studying why that is.
Dr. Ruth Gates is director of the Hawaii Institute of Marine Biology. She spends most of her time here in these waters, studying what's happening under the surface.
Okay, Ruth, where are we headed today? Today, what I'm going to show you is corals that are different in color. White, brown, or dead.
Different levels of health then.
Exactly.
It's a small crew. Dr. Gates and myself, team members Jen Davidson and Beth Lenz, and the boat's captain, John L.J. Benson. This won't be leisurely. We're racing the elements. In the mountains overlooking the bay, a storm is threatening. It's an ominous day to go scuba diving, but science doesn't wait for perfect weather. Near our dive site, Beth and Jen jump in with snorkel gear to help us zero in on the reef below. The event that brought us here is called bleaching. Higher than normal water temperatures cause corals to expel the symbiotic plant cells which provide them food. Without the algae, the corals begin to starve, turning healthy brown coral ghostly white. This year's bleaching has been so pervasive that for only the third time in history, scientists have declared it a global event. Back on board, I check out a new piece of equipment, an aquatic communication system that will let me talk underwater. Jen and Beth surface, confirming we're on the reef.
Directly under me.
It's directly under her. We'll do it, because this coral is really amazing.
With the weather still holding, though barely, we gear up.
Let's try this monster out.
There you go. Snug it up.
And, one by one, experience that moment that any diver worth their salt never tires of.
1, 2,
Falling from one world
3.
into another. Almost immediately, I see it. Brilliant white coral, an unmistakable sign of bleaching. And then more, and then more.
It's really beautiful, but you can see signs of bleaching. There's lots of brilliant white coral here. That's not a good sign. This reef, despite being in a process The bleaching is still teeming with life.
And then, an example of what is really at the crux of Dr. Gates's research.
This coral here has the 3 stages that Dr. Gates has been talking about. There's the completely dead coral, where you can see there's got that fuzzy appearance, green. There's coral that's bleached, which is obviously this brilliant white. And then there's coral that's in the process of recovery.
One species of coral, 3 separate outcomes to the same set of environmental conditions, and that underlying question of why. Beth and Jen collect samples of these types of different performing corals to bring back to the lab, and then tackle a task essential for long-term monitoring research: tagging coral.
The even number on the tag indicates that this coral is essentially healthy. The odd number tags are corals that have bleached. This is important because you need to be able to follow one individual over a long period of time.
That was awesome.
I get back on the boat, exhausted but exhilarated,
All right, that was fun, but definitely tiring.
but also concerned about what I saw. How are corals doing on a global scale?
Corals aren't doing very well at all, and they're not doing well for a variety of reasons. First of all, we have changes in our global ocean that relate to climate change. And so the ocean is getting warmer and more acidic. And corals don't like warm water, and they definitely don't like water that is a little bit lower in pH.
It's no coincidence that the 2015 bleaching event coincides with an El Niño year, a global weather phenomenon which causes already rising sea surface temperatures to spike even higher. The consequences for reefs can be devastating. Today, approximately 38% of the world's reefs are bleached, from Australia's Great Barrier Reef to the Caribbean to the islands of the South Pacific. The rain picks up almost the moment we pull anchor and continues to pour as we reach the docks of Coconut Island, the Hawaii Institute of Marine Biology's home.
It rains in paradise, apparently.
While LJ secures the boat, Jen makes the trek through the rain and mud to the wet lab and deposits an example of healthy coral and of bleached coral into the holding tanks. Coming up, supercorals. Is what you're creating here a Frankencoral? Scientists race to get corals ready for the impacts of climate change. Around the world, coral reefs are in crisis. They are facing a multitude of threats, the latest being a global bleaching event that's impacted 38% of the world's reefs. I've come to Hawaii to see the bleaching firsthand. And despite the telltale signs of corals in peril, there is an unmistakable beauty to be found here, both in the ocean and, more surprisingly, in the lab. Hawaii Institute of Marine Biology researcher Amy Eggers prepares a sample of coral from microscopic analysis. The resulting images reveal an amazing world. This is what live coral samples look like under the hood of a laser-scanning confocal microscope. The scope is equipped with 6 lasers that excite the molecules within the coral, revealing their natural fluorescence and turning live corals into what look like works of art.
So this is a brown color. Is this essentially what we see when we're out on the reef?
Exactly. We saw brown corals and white corals on the reef yesterday. This is a representative of a brown coral.
Dr. Gates uses the microscope to see something she cannot see with the naked eye: signs of life, important for determining the inner functions of corals like this, which are brimming with life. Even more so for detecting it in bleached coral, such as this one.
This would be, from what we saw yesterday, would be a representative of a white individual on the reef. And what we are really interested in using the scope This looked totally white to us. Our eye is not sensitive enough to pick up the fact that there are still residual plant cells in there. We think that when an animal loses every single one of its cells, it dies.
So this is essentially telling you that this coral is not dead. It
not
still has a little bit of life left in it.
Understanding a coral's reaction to stress events and measuring its threshold is central to Dr. Gates's project and the deadline it's up against.
Today, we are facing the potential loss or massive degradation of all of our reefs by 2050. That's not me saying that.
That's astounding.
It's astounding. If we don't have coral reefs, we will have people who don't have food, who will have to move, whose lands, their entire islands will be eroded. And the tourist economy of many of these places will be completely obliterated.
And from her lab in Oahu, Dr. Gates is working on a creative, if somewhat controversial, scientific solution.
If you could get a coral to change and acclimate or adapt in the same time frame, the rate at which the climate is changing, if you could actually adapt your corals to keep up with that.
What you're talking about here is epigenetics,
Absolutely,
right?
rapid adaptation.
Gates team member Dr. Holly Putnam's job is to predict the future of climate change, or at least to try to simulate it in these tanks.
So what we do is we bring in corals from the field, and then we fragment those individuals into different pieces and expose them to different conditions. So in here we have a fragment of that adult colony that's exposed to, say, high temperature or high CO2. In this particular instance, it's high CO2, and that would simulate future ocean acidification.
It's the first step in a process called transgenerational acclimatization. In this case, preconditioning an adult to ocean acidification and then measuring whether the offspring are then better equipped to handle that same stress event.
What are you seeing?
So they're growing faster and they're surviving at a higher rate if they were preconditioned to the high temperature and high CO2 and then re-exposed to that high temperature and high CO2.
Yeah, so it's almost like you're training them to withstand the conditions that the future might hold.
The last step in the process is taking the preconditioned offspring and returning them to the reef for further monitoring.
I want to make sure that we're really clear here, because a lot of people will hear selective breeding and think genetically modified. Is what you're creating here a Frankencoral genetically modified organism?
It is not. What we're doing is just assisting the evolution of corals. That is, we're trying to accelerate the rate at which they do things to keep pace with the rates of change that are in the environment today that associate with climate change.
Science provides one picture of what the future of coral reefs looks like. But outside of the lab, Kimokeo Kapahulehua provides another.
Malama kamuwana. Take care of the ocean take care of you. If we poison the ocean will poison us.
Kimokeo takes me on a traditional outrigger canoe for one final visit, to an area known as the Coral Cemetery. This is what becomes of coral when it has died, and its remaining skeleton becomes brittle and collapses.
When I think of a coral reef, I think of an ecosystem that is full of life, colorful, structured, almost cathedral-like. I have to say, I'm a little heartbroken right now because where I'm standing is indicative of what might happen to corals if the threats go uncontrolled. They'll probably look more and more like this.
From the rainforest of the seas to a lifeless pile of rubble. And without change, it's a fate that could befall the world's coral reefs within most of our lifetimes.
I've never seen coral bleaching like this. I've never seen this happening, you know, where you're seeing entire mounds of coral that are just completely on the verge of death.
How does that make you feel?
I was sad. You know, it made me actually really, really sad to go through there because I think of a coral reef as, I mean, it's just this iconic system. For me, it was almost a spiritual experience to be in this area that just is teeming with life. It's so beautiful. Everywhere you look, there's something's happening, right? And then you see these indications of sickness, and it really was sad.
When I look at a rainforest, for me, I don't just see trees, I see the home of a lot of different organisms. They live there, so when it gets destroyed, you're destroying their homes. So I'm sure it must have been kind of similar for you, seeing this coral just be kind of empty.
Totally. I mean, and coral, much like these large trees and these canopies, they are a structural component, right? They literally are providing a home for lots of other things to live, places for fish to hide, places for things to feed on. As we saw in the piece, if this trend continues and nothing happens, these majestic, almost cathedral-like reefs are going to become rubble, like the beach we saw.
Your experience, do you think this type of human intervention, this type of directed evolution of corals is really going to be the silver bullet that we need?
There really is no silver bullet. We have to take a multi-pronged approach, and I do think that the assisted evolution is a very key component of this.
It's a very useful tool, but we won't know how good it is unless you put in the time to research it. Just like all these other avenues, they got to do their time, and hopefully it turns out well.
Yeah, I mean, the good news is that they're seeing results, you know, and within the single lifespan of one individual coral, they're able to condition them, and they're starting to see that that's being passed on to offspring.
Well, thanks for an amazing piece, Maria. That was, I mean, absolutely beautiful, so I have to give a shout out to the crew to get that underwater photography stunning.
Absolutely beautiful.
Yeah, not easy to get at all.
Marita, you're from Seattle, so you must have a little bit of oyster pride. Pretty amazing up there.
Oh my gosh, I mean, one of the things I love about Seattle is that I have access to oysters, and I love oysters, but they've been really hard hit by climate change. And you guys know, on TechKnow, we've followed the sad story of ocean acidification and the impact that it has on the oyster farming business, which is a big deal in Washington State and elsewhere.
The problem is just really simple chemistry. Acid from carbon dioxide in the water is just making it really hard for young oysters to form their shell.
There could be some hope for them. There are ways of reducing the acidity of the water. We hooked up with some marine biologists in Northern California. The oysters are awesome, and science is making some progress. Let's take a look.
This is Tamales Bay, California, a little slice of heaven about 90 minutes north of San Francisco. This is where you come for the freshest oysters.
Order for Missy.
Served up straight out of the bay.
Ooh, the cooked ones.
People love to picnic here, right along the Coast Highway.
It's like awesome. Yeah. What do you need? Family, oysters, sun, water. The best.
I think it's delicious. Honestly, fries, burgers is my life, but oyster is pretty good.
Lately, the oyster business has been very good.
It's really, really busy. 4,000 oysters today. Maybe pushing 5 if we're lucky.
But this is also one of those places where the future is now. Climate change is a reality here. All along this bay, oyster farmers are fighting a hidden enemy, ocean acidification.
This is an ocean acidification monitoring system.
Tessa Hill is associate professor at UC Davis's Bodega Marine Laboratory. And this is her makeshift lab. Can't get any closer to the action. Right inside the pump room at one of the largest oyster farms here, the Hog Island Oyster Company.
So that actually gets so bad that the oysters will dissolve.
Well, right now it's getting bad enough that the oysters are stressed by it, or it's not easy to make shell.
TechKnow first came to Tamales Bay and Hog Island oysters in 2013.
So he's gonna dive down to the seawater intake system.
Terry Sawyer is the main man here at Hog Island Oyster Farm. He's also had to learn a lot of chemistry and marine science just to survive.
What we're seeing is all the larvae or the juvenile oysters, the entire populations are crashing, they're dying. It's alarming to say the least.
As TechKnow first reported in 2013, ocean acidification is caused by the addition of carbon gases in the ocean. That's caused an increase in the presence of carbonic acid, leaving shellfish like oysters less calcium carbonate, the key ingredient needed to form their shells. It hits the oyster crop hardest when they're young and fragile, but even the more mature oysters that fill the beds out in the bay are vulnerable. We've come back to the bay to see if anything has changed.
Hey guys.
Sawyer met us at the shoreline. We had a boat waiting.
So this is a Hog Island boat?
This is one of our harvest vessels.
We're heading out onto the bay to check out a potential solution Tessa and the UC Davis team is researching.
Is this prime time for seagrass?
Tide's dropping, the seagrass is actually getting closer to the surface.
Turns out seagrass is showing some promise, mitigating the effects of CO2 in the water.
Seagrass, because it utilizes photosynthesis, is actually taking carbon dioxide out of the water. That's what's making the water acidic.
Okay.
So it's actually removing carbon dioxide in sort of a local area and therefore buffering against the impact of ocean acidification in a very small area.
The bay here is a 15-mile long, 1-mile wide stretch of water, large enough to support the millions of oysters raised here, but small enough to see the impact of a localized ecosystem. Seagrasses are flowering plants that live in marine environments. There are some 58 species of seagrasses known to marine biologists. Since they survive on photosynthesis, they tend to live near sunlight or in shallow waters. Seabeds are diverse ecosystems supporting fish, algae, and, yes, oysters.
So right now, this grass below us, it's actually doing a service.
It is. It is doing a service. We're finding that it's complicated.
Complicated because of this. When the sun shines, seagrass absorbs carbon. But at night, the opposite happens. Photosynthesis stops and respiration is dominant. Carbon is released back into the water.
So how do you guys monitor what seagrass beds are actually doing?
We actually place sensors that measure temperature and salinity and pH and carbon dioxide and oxygen inside the seagrass beds themselves. And we let the sensors sit there for weeks at a time collecting data.
It is still too soon to know what, if any, long-term promise seagrass holds. It may only work in a small, localized estuary like here in Tamales Bay, but that's a start.
When I look around here, it is beautiful. The oysters taste great. But for you, it's a bit of a laboratory.
It is a natural laboratory. It's also very beautiful.
But the fact is, it is something that we're down in it. We're seeing it now. We're beginning to test it. And we're able to understand more about what's going on and under the water and above the water.
I really do love sort of the innovative approach of using the local resources to affect, this single problem.
Yeah, it's such a great example of industry and researchers working together, saying, okay, there's this big issue, how can we work together to try to solve it?
And the other thing I love is that, this is a follow-up on a story that we did in 2013, and we've been able to see the progress that the research has really informed, and so it's nice to see that something's actually happening, and that it's happening on a fairly quick timescale.
So we've talked about coral in trouble, we've talked about oysters in trouble, but we've also met some really innovative people trying to help, and they're making some really good progress. So we'll be sure to keep you updated on these stories. Be sure to check in next time here on TechKnow.
Dive deep into these stories and go behind the scenes at aljazeera.com/techknow. Follow our expert contributors on Twitter, Facebook, Instagram, Google+, and more.